We are talking about simplifying radicals. We want to simplify radicals in different forms and use conjugate pairs to simplify radicals. One of the processes we have to do is rationalize the denominator. So we don't like having the square root in the denominator like we have in these three examples. So one way to get the radical out of the denominator, if we have this first example, x divided by b squared, is to multiply by the square root of b over the square root of b. And basically what this is saying is, if we were to plug this into our calculator, this is just saying that we're multiplying by 1. It just looks different. If we type in our calculator square root of 2 divided by square root of 2, so if we said square root of 2 divided by square root of 2, and we type that in our calculator, that answer is 1. So even though it looks different, the value is still 1. And the reason that it's important to understand that we're just multiplying by 1 is because if we said x multiplied by 1, does that change the value of x? No, that is still x. Now in this case, we multiply by the square root of b over the square root of b. It's going to change the way that it looks. We can see that over here it says x times the square root of b over b. And over here it says x divided by the square root of b. They look different, but the values are still the same. The value does not change. One other example that we can think of, if we said like square root of 2 divided by square root of 2 is equal to 1, also 2 divided by 2 is equal to 1. So as long as we multiply something by the same numerator and the same denominator, it's not going to change the value because it's just still equal to 1. And that's the same thing with these bottom two examples. Here we're multiplying by a minus the square root of b divided by a minus the square root of b. Because the numerator and the denominator are exactly the same, this is like saying multiplying by 1. So that's just the same as multiplying by 1. So although the look changes, it's still the same value. And we're going to take a look at how, if we multiply, and this is the conjugate pair. So if we multiply by the conjugate pair here, that simplifies the radical, because here we have a minus the square root of b. Here we have a plus the square root of b. So we multiply by the conjugate pair because when we do this multiplication, the middle terms drop out. And I'll show you an example. So if we had in the denominator, we'll say 2 over 2 plus the square root of 2. We don't want that square root in the square root of 2 in the denominator. So we're going to multiply by the conjugate pair. So conjugate pair says same two terms of the binomial, but change the sign in between. So we keep the same two terms, which are going to be 2 in the square root of 2. And we're going to change the operation in the middle. Now, in order to make sure that we're not changing the value, we got to make sure that this remains 1. So whatever's in the denominator has to be the same that's in the numerator. So when we go and multiply this, in the numerator, we're going to take 2 and we're going to distribute it to both the terms in the numerator. So 2 times 2, that's 4. And 2 times negative square root of 2, that's negative 2 square root 2. We can't multiply those together, but we can write them next to each other, joined by multiplication. Now for the denominator, we have to distribute each one. So 2 times 2 is 4. And 2 times negative square root of 2 is negative 2 square root 2. Then we have the square root of 2, positive square root of 2 times 2. That's positive 2 square root 2. And then we have square root of 2 times negative square root 2. That's going to be negative square root of 4. So when we're looking at this, the 4 comes down in the denominator. Now we have a negative 2 square root 2, and then we have a positive square root 2 square root 2. So these actually cancel each other out. And then we know that the square root of 4 is 2. And we can't do anything with the numerator. That just stays as it is. So 4 minus 2 square root of 2. And then we can keep simplifying from there. In the numerator, we can't do anything with that right now. So that's just left as 4 minus 2 square root of 2. 4 minus 2 is 2. And the last thing we can simplify is we can divide the 2 by both terms that are above. So 2 can divide into that term, and 2 can divide into that term. And then we get 4 divided by 2 is 2. And 2 divided by 2 is 1. So it's 2 minus the square root of 2.